Hello, welcome back. This is Algebra 1, Lesson 2.9, also known as Module 2, Page 9. We are today going to talk about linear inequalities. And so, what is a linear inequality? Well, if you think back to some of the lessons we've gone over just recently, we had been learning about how to graph linear equations. So, if we have a linear equation, let's say we have y equals 2x plus 3. Okay, y equals 2x plus 3. We need to first find out a point in order to graph this. The easiest point, since this is in slope intercept form, is to find the y-intercept. The y-intercept always has 0 in the x spot, and this b value here is the y for the x-intercept, so 0, positive 3. So that means right here is our first point. Now, the second thing you need to graph on, need in order to graph a linear equation is going to be the slope. Remember, the slope is m right here, the coefficient to the variable, so just the number 2. But remember, we need it in the form of a fraction because we need both numbers, rise over run. So it's 2 over 1. That means I'm going to go up 2 and to the right 1 to get my second point. Now, all you need to graph a line is 2 points, but we can graph a third one. Remember, negative 2 over negative 1 is the exact same thing as a positive 2 over a positive 1 because two negatives, an even amount of negatives in a division problem is going to make a positive. So if we had negative 2 over negative 1, that would mean we could go down 2 and over 1. So you don't have to only go in one direction when making your line or your slope. If it's more convenient to go a different way, you can do that as well. So here, I'm just continuing to go down 2 and over 1 just to make sure I'm got my line really set here, right? And I can already see how it's working out. And then I connect my line, and using the electronic pen is really hard for me to get a straight line, but I did pretty decent there. When you're drawing your graph on paper, you can always use a straight edge like a ruler or the edge of a book. That will help you make sure you get your straight line and you've gone through every point. See how I kind of curved around that point a little bit and went off the edge here. So this is how we graph the line y equals 2x plus 3. But Miss Andrea, you said we were going to be going over linear inequalities. That's a linear equation, not a linear inequality. Okay, well, let's think back to some not linear inequalities, just inequalities we've worked in the past. When we worked, when we solved inequalities in the past, we only had one variable. Remember, we had 9 is less than 2x plus 3. Now, there was a rule for solving inequalities. If you divided or multiplied by a negative, you would what? That's right, you'd flip the inequality. So let's solve this for x and see what we get. All right, so 9 minus 3 is less than 2x. I took this 3 and I switched sides, so I switched the signs, or you could call it subtracting 3 on both sides. 9 minus 3 is 6 is less than 2x. Okay, now I'm going to divide both sides by 2 to get rid of that, so I'm going to have 3 is less than x. Okay, well, I've solved it, but we were also graphing inequalities back when we solved this, right? Well, how did we solve this? We had, okay, well, this is 3, this is 4, this is 2. A less than meant we had a hollow point or a hollow dot my X is on the wrong side for graphing. So let's flip this. If we flip the whole thing, we need to include flipping our inequality here. So X is greater than 3, which means I'm going to graph this side. Well, am I graphing a line when I graph this? It sure does look like a line. I mean, it's on the number line, isn't it? Well, what we're actually graphing here is not a graphical representation of the line. What we graphed is an image of all the possible answers that would work for X here. Because anything greater than 3, 3.1, 3.7, 5, 1,225, all of those numbers, anything on this side is going to work as a solution for what X is. So what we graphed is the solution set. This is all possible answers that fit this inequality that we have. So this is a graph of a solution set. It's not a linear inequality. To have a linear inequality, you would have to have both an X and a Y, or two other variables, but you would need to have two variables which are not raised to any exponents. The variables can't be raised to any exponents. So let's look at if we had this exact same equation here, but instead of equals, let's say we had less than or equal to. Okay. Well, if you remember back in when we were graphing the solution set, we had two different things we could graph. If we had less than or greater than, our points were hollow. But if we had less than or equal to or greater than or equal to, our points were solid. Well, that's for solution sets, a single point that changes. But when you have a linear inequality, how it changes is you have a dashed line for less than or greater than, and a solid line for greater than or equal to or less than or equal to. Now, in addition to that, we're going to have to graph or shade in 1/2 of this graph. So it's either going to be this side, the left side of the graph we're going to have to color in, or the right side of the graph we're going to have to color in. Well, how do we figure that out? We just pick a point. We test it and see. So I'm going to pick this point here, 0, 0. And if I that's the point, 0, 0, right? So our X value is 0 and our Y value is 0. If I plug that in here, Y, this is my equation, right? So I'm going to plug in 0 is less than or equal to 2 times 0 plus 3. Okay, 0 is less than or equal to 0 plus 3. 0 is less than or equal to 3. Is that a true statement? Now that I've done all the math part of it and worked it out, is it true or is it false? Well, let's look at it. 0 is less than or equal to 3. I know it's not equal to 3, but 0 is less than 3. So this is definitely a true statement. And so that means I would be shading in this side of my coordinate plane of my graph here. And that tells me that any single point in all of this shading, anything, this point, this point, this point, this point, this point, it doesn't matter which point, they all work. They're all possible solutions. They will fit the inequality. Y is less than or equal to 2x plus 3. Well, Miss Andrea, what if I had chosen a point on the other side of the equation? What would have happened then? Let's go ahead and do that. Let's change colors here just to make it a little easier. So this point right here is -2, 1. Okay, so we have for the X value -2 and for the Y +1. So I'm going to put Y, which is 1, is less than or equal to 2 times -2, which is the X, plus 3, because remember, I'm using this equation here still. Okay, I'm just plugging in the x and the y. So y is less than or equal to 2 times negative 2. Okay, well, I have an odd amount of negatives, so my answer is going to be negative. And 2 times 2 is 4 plus 3. 1 is less than or equal to negative 4 plus 3. Different signs, I find the difference. So 4 minus 3 is 1. And then the larger value, that sign goes on my answer. So negative 1. 1 is less than or equal to negative 1. Let's think about this. Is this true or false statement? Well, 1 is not equal to negative 1. They're exact opposites, right? Is positive 1 less than negative 1? No, positive can never be less than negative. That doesn't make any sense. So this does not work. So if I'd chosen that one first, I would just say, okay, that side doesn't work. And then I'd choose something on this side just to make sure. It most likely would work, but we still want to verify it because math is about the details. And then you'd graph this in. Okay. So I want to go ahead and show you some a graphing, online graphing thing that we have here. So this is called Desmos. And it's really cool because it allows you to plug in your equations and see what you would graph. Like, what were we just looking at? Let's start with the linear equation that we had. I think it was y equals 2x plus 3, right? That was our linear equation that we had. I believe that's what we were working on. Was it plus 3 or minus 3? I think I wrote plus 3. All right, so this was our linear equation that we were just working on. Well, what if I can also add a second equation here? Y is less than 2x plus 3. And you can see that it graphed that one in green, and it shows us that it's a dashed line. This here is telling us it's a solid line, okay? We can turn off the blue one so we can see the green one a little bit better. There you go. Okay. Well, what if it was the other way? Y is greater than 2x plus 3. Okay, that one's in purple. Let's turn off the green one. There you go. That's purple. Okay, let's turn back on this first one. That's that solid line again. So you see they're all around the same equation. Well, what if I wanted y is less than or equal to 2x plus 3? Okay, it graphed that one in black. And you can see here that it's a solid line. And it's showing us that it's an inequality here, that one side's shaded and the other's not. Right here we have the shaded region, right? And so you can go back and turn these on and off as you need to see them. And it's a great tool to help you check your work and see if you got it correct. You still need to be able to do it by hand because you cannot graph this use this calculator, this graphing tool rather, on your exam. You cannot use it on any quizzes or tests, only on your ungraded assignments. But it does help you to learn. So I did want to make sure to show it to you. So now let's go back. Now that we know how to graph these linear inequalities, and I want to give you some practice here. So we have for you 5 questions. Go ahead and pause the video. I want you to graph these. You should have graphing paper to do it on. If not, line paper is fine. You just have to draw in some extra lines to turn it into graph paper. But here are your equations. Pause the video, work it out, and then come back to us. All right, welcome back. I have the equations here. I'm actually going to try to graph it on our Desmos graphing paper, digital graphing paper, just to try and make it a little easier for me so I don't have to draw out the graph every time. All right, so the first one we have is going to be y is less than, nope, I'm sorry, it says greater than negative 2x plus 3. So we know our y-intercept, and then m is going to be negative 2 over 1. So down 2 over to the right 1. Down 2 to the right 1. Now, is this going to be a solid or a dashed line? Well, it looks to be a dashed. Oops, I'm not doing so hot with my dashed line here. It should have been more like that. Let's see if I can erase this here. There we go. Now, how do I know whether to graph my right side or my left side? I'm going to think, since y is greater than, it looks like this y is greater than. So I want to choose something up here. So I'm going to choose right there. Okay. And that point is 0, 4. My x is 0 and my y is 4. So let me plug this in. 4 is less than negative 2 times 0 plus 3. 4 is greater than 0 plus 3. 4 is greater than 3. And that's a true statement. And so this is the side of my graph that would be shaded in. All right, since we are on Desmos, we can actually just plug it in here and see if we got it correct. Look, it's in red, but it's the same thing. A dashed line, the same side is shaded, and we have our line going through the same points that we plotted. Looks like we got it correct. All right, so the next point that we had was, this one was a little trickier. It said x is less than negative 2, right? Isn't that what it said? Oh, I wrote on here y is greater than negative 2. All right, we'll go with that one. That's not what we'll do both, because the online book has it as x is less than negative 2. So let's go with this one first. I know you weren't doing this one, but it's pretty easy. So go ahead and do it now along with me. X is less than negative 2. We know that it is a vertical line when x would equal negative 2, right? So x is less than negative 2 is going to be a vertical line as well, but it's going to be dashed. So it's going to look like this. Every single x is going to be exactly right there. Now x is less than negative 2. Which x's are less than negative 2? These are, not these. All right, let's plug it into Desmos and see if we got x is less than negative. Oops, I did positive 2, so it's going to be wrong. Get ready. Negative 2. There you go. I did positive 2 instead of negative 2. Details matter. Negatives are very important and easy to mess up. But you see, it's just a vertical dashed line that's shaded on this side. Okay, well, what about the one I actually had given you? What is that going to be? All right, let's look at that. What I had given you was, it looks like it was y. I think it said is greater than negative 2. So let's look at this and see. Y is greater than negative 2. That is what it said. All right. So we know that this, if it's a y equals, remember y equals negative 2, we know that it's going to be a horizontal line. I'm going to get my negative. I'm going to pay attention this time. It's a negative. So a horizontal line is going to go across here, right? And horizontal and vertical lines are pretty easy to figure out which side you're going to shade. If y is greater than negative 2, well, 1 is greater than negative 2, so it's going to be this side right here. Let's plug it in and see. Y is greater than negative 2. Look, we got it exactly correct. Good job. All right, our next equation that we had, let's clear this, is y is greater than or equal to negative 1/2 x plus 1. Okay, we know that our y-intercept is 0, 1. So we're going to plot that point first. 0, 1 is this point right here. And then we know our slope is fall or down 1 and to the right 2. So down 1 and to the right 2. Down 1 and to the right 2. It also works this way. We can go up 1 and to the left 2. Remember, if we switch it, we have to switch both of them. Now, is my line going to be solid or dashed? Well, it's going to be solid. And that means I'm going to have to try to do a good job of making sure I get it right. Okay. Now, it says y is going to be greater than or equal to. So I think I want to choose, if this is where it intercepts the y-intercept, I'm going to choose something up here because I think that's going to have a better likelihood of being greater than or equal to. I don't know, though, because of this negative on the slope. So let's think about this. This point is point 0, positive 2. X is my 0, y is 2. So I'm going to plug this in. 2 is greater than or equal to negative 1/2 times 0 plus 1. 2 is greater than or equal to 0 plus 1. 2 is greater than or equal to 1. Is that a true statement? 2 is not equal to 1, but it is greater than 1. And so this is the side that I would have graphed or shaded in rather. So let's plug it into our Desmus graphing situation here and make sure that we can get it. Negative 1/2 x, oops, go off to the side, x plus 1. And it looks like we got the exact same thing they did. So we are definitely correct. All right, let us do the next one. We had y is less than 2x. Okay, first thing we need to find is the y-intercept. This is in y equals mx plus b format, but our b in this case seems to have disappeared. And when things disappear, let's think about it. If we added 0 to this, it would not change the equation at all. So our y-intercept is, the x is going to be 0 because a y-intercept always has an x of 0. And then our b happens to be 0 will be the y value. So 0, 0 is our y-intercept. All right. So now we need to find what is our slope going to be. Our slope we know to be 2, but we need it to have 2 numbers. So 2 over 1. So let's go up 2 and over 1, up 2 and over 1. Same thing, and we could go down 2 and to the left 1. Okay. Now, do we need a dashed or a dotted line? Well, we need a dashed line here, and hopefully that's a decent enough job. And it says y is going to be less than 2x. So I think I want to choose this point because on the y-axis, it is below it. So we're going to plug these in. This is coordinate 0, negative 2. So my y is the negative 2. And my x is 0. So negative 2 is less than 0. Is that true? Yes or no? Is that math statement true? Math inequality true? Negative 2 is less than 0. Yes, that's true. And so that means I'm going to shade in this side of my graph. All right, so let's plug this in. Y is less than 2x. Yay, we did it. Reminiscent of Dora. We did it, we did it. I don't even remember that song anymore. It's been so long. All right, So now we have one that I can't remember if I gave it to you, how I gave it to you. Ooh, I gave it to you like that. Okay. 3y. Let's write this out. We had 3y is plus, or I think it said minus 9 is less than or equal to x. Let me just make sure that's what I gave you. 3y is minus 9 is less than or equal to x. Okay. So in order to graph this, we need to first find a point. You have to have 2 points to graph a straight line. But it's hard for us to identify a point with this equation because it's not in slope intercept or point intercept format, which allows us to easily identify some points. So a format that's always easy to get to is the slope intercept format, the y equals mx plus b, because all you have to do is solve for y. So what we're going to do is just solve for y here. That's going to be our first step. So we're going to add 9 to both sides. Okay, so 3y is less than or equal to x plus 9 because these canceled out, right? And then we have to divide by 3. And remember, when you divide by 3, you have to divide every single term by 3. Okay, so you're left on this side with just y is less than or equal to, well, in this case, since x is in the numerator, it's going to move to the side. The 3 is going to be on the bottom, and the coefficient of the x is going to go on top. What is the coefficient of the x here? It's a 1. So this is 1/3 x plus, what's 9 divided by 3? It's 3. So our equation is y is less than or equal to 1/3 x plus 3. Now we can graph this. We have the y-intercept, 0, 3. That's where we're going to start graphing, 0, 3. Then we know what our slope is, m equals 1/3, okay? We're going to go up 1 and to the right 3. Alternatively, you could go down 1 and to the left 3, okay? So we have our line set. I just graphed 3 points. You only need 2 in order to graph a line. Now I need to know, am I going to be solid line or dashed? It's going to be solid because of that equals underneath it, as a part of the inequality. And here we go. Now I need to choose a point to graph with this. And I had y is less than or equal to, so I'm going to choose a point that's below the intercept. So I'm going to choose 0, 0. Okay, so y, 0, 0 means I have an x and a y that's 0. So I should be putting a 0 here. 0 is less than 1/3 times 0 plus 3. 0 is less than or equal to 0 plus 3. 0 is less than or equal to 3. Is that a true statement? Yes, 0 is less than 3. That is a true statement. So this is the side that we would shade in, right? All right, so since this is our final equation, I don't want to not check it. So let's put it in its original format. 3y minus 9, let's go here, is less than or equal to x. Look at that. We got the exact same formula or graph with the same thing shaded. We have a solid line. It's going through all the points that we chose. You can see my line is a little wobbly. And then the same side that we shaded is shaded by the calculator. And we didn't even put in the one that we manipulated. We put it in the original equation and still got it. So this is a great tool to check your work with. I highly encourage you to use all of the tools you have at your expense to be able to learn and grow and understand the material prior to taking any graded assignments such as quizzes or tests. All right, we'll see you back in a moment for 2.9.